Alright, what's up everybody? This is looking at the electricity explained homework. I'm going to go through each one quite quickly, pointing out the mistakes and the bits that are really good. So we looked at anesas already. Just to highlight again, the main problem was saying that the charge on an electron can be positive, which is not correct. Everything else was pretty good there. There was nothing really incorrect. It wasn't super high level in terms of the answer, but most of what was said there was correct. So cool. Move on to PhysG. So PhysG's here. Electric current is a flow of charge. Yeah, definitely correct. Charges flow around the circuit. They give away energy. Yeah, this is right, especially when they go through a bulb or a resistor. Energy is transferred into other forms by the components of the circuit. A bulb transfers electrical energy into light energy. This energy is called the voltage. Yeah, that's kind of right. This last sentence I'm a little bit concerned about. The energy the electrons have is the voltage. The voltage is a measure of how much energy is carried by 1 coulomb of electrons. So yeah, good effort there. We can see she took 19 minutes to write that. Pretty slow writing. Maybe she was eating while she was doing it. But yeah, that's pretty decent. There's nothing really wrong with that. On to Judy. A circuit is like a road made out of wires, allowing a current of electrons to pass through. Okay, yeah, cool. Helping the battery give out the voltage. Well, nothing really helps the battery give out the voltage. It naturally gives out electrons which have a voltage with them. The electrons can start moving. Yeah, that's correct. The switch is used to stop or allow that electron to go through the wires and reach the bulb. And then we should talk about how after it leaves the bulb, it goes back to the battery. So yeah, not bad. May's answer. When you switch on a bulb, do you switch on a bulb or do you switch on the circuit that the bulb is connected to? The charge moves through the wires and the voltage, energy per electron, from the battery gives the charge the force to push through the pathway. Yeah, okay, that's cool. That creates a current that lights up the bulb. Yeah, that's pretty good. Probably should go into more detail there about how energy is transferred to the bulb. There are some really good bits in there, but it's not detailed enough. On to Diana's. An electrical circuit is like a pathway made of wires that electrons can flow through. Yep. A battery or other power source gives the voltage that makes the electrons move with energy. Yeah, I'd agree with that. The electrons go to the bulb, give it the charge to switch on. Now, they don't really give it the charge. The electrons carry charge. It's part of their property, but they give it the energy to switch on. Current will be the same in all parts of the circuit. Yeah, if it's a series circuit, it decreases as more loads are added. So this is saying if you add more bulbs, which is bigger resistance, the current will decrease. And you can see that from Ohm's law. Yeah, pretty good effort there, Diana. Aya El Hariri. For a circuit to work, what is this? Is this text speak? You need bulb switch wires. Okay. Grammatically not very good there. I'd agree that you need these things, but you're missing a battery, a power source, the most important thing. Voltage pushes the electrons, yeah, and the current is how many electrons are being used. It's how many electrons flow past a point per second, okay? Amps is the unit of current, correct? The bulb will light up when the energy goes through the wire. Again, we need to be more specific here. The bulb will light up when energy from the electrons is transferred to the bulb, creating light energy and some wasted heat. Aya El Saka. A circuit has wires which allows electrons to pass through. Yep. The flow of electrons is also called current. Yes. An electrical circuit consists of a battery, which is the power source. Yes. A conductive pathway, which allows the movement of charge. This is the wire. Yes. A resistor, which are the objects, bad grammar here, that uses the electricity, e.g. a bulb. Good. Yeah, I suppose that's correct. Yeah, a bulb is a type of resistor. Switch, which opens and closes an electrical circuit. Cool. The battery gives the voltage, which is an electromotive force, or potential difference expressed in volts. So we've got these key words in here. The battery provides the electromotive force, and we measure the potential difference between 2 points. The volt is what makes the electrons move. Yeah, they have that voltage. They have that energy so they can move. The electrons, charge carriers, travel through the wire until they reach the bulb. It gives them the power. We should use the word energy here. It gives what is this? It gives what? The bulbs? It gives the bulb the energy, so it turns on and gives out that energy as light, sound, or electrical energy. Yep, generally pretty good. A few misconceptions, but fine. Sarah. To make a circuit work, you need a battery, a switch, wire, and a bulb. Yeah, okay. You don't actually need a switch, do you? You don't need that, but fair enough. In a circuit, when the switch has a gap, it means the bulb won't light since the electrons cannot flow. Yep. The electrons carry charge from the atom. What? You mean from the battery or from the cell? The force the electrons are being pushed with is called the voltage. No, voltage is the energy that the electrons have. The electrons do experience a force, but you won't learn about that till A level. Current is the flow of electrons through a circuit. Current is the flow of electrons through a circuit. It's the rate of flow. It's how fast they flow. Yeah, not bad. Maybe a bit more effort needed. Haneen. The current in a circuit is the electrons that go around the circuit from the negative pole to the positive pole. Okay, so the electrons flow, but don't get confused with conventional current, which goes from positive to negative. The circuit has voltage, which makes the electrons flow through the circuit. Careful here, this is just lazy. It means you're not really rereading it, you're not checking over it. The circuit has voltage. I have an issue with that. The battery has a voltage, and there may be voltage used up across a bulb, but the circuit doesn't have a voltage. Not really, that doesn't make sense. It has a charge, which is measured in amps. This is nonsense. What has a charge? Charge isn't even measured in amps. Amps is the measurement for current. Charge is measured in coulombs. Okay, so this is absolute rubbish here. That is the worst sentence I've ever read in my life. As the switch is turned on, the electrons and energy in the circuit flow around the bulb lights. Good, that's all right. The battery then has volts as well. This is nonsense. Okay? The current is the flow of charge in a circuit. Yes, that is correct. It's measured in amps. Okay? Quite a lot of problems with that one. On to Sapphire's. If it ever loads. Wow, loads. Taking 36 minutes to do this. Good job, Sappha. A battery makes the electrons in the circuit move around. Yes. If a bulb is added to the circuit, it will light up. This is because electrons flow through it and heat up the wire in the bulb. Yeah, really good. Well done. A switch controls when you want to stop electrons from flowing, meaning when the switch is opened, there will be a break in the circuit which will stop electrons from moving. This is why I always used to get mad at Judy last year when she's like, "Sir, can we open the lights?" Because opening a circuit breaks the circuit, which turns the lights off. Open the AC, sir. Sir, can I close the AC? Current is measured in amps, yes, which can be measured using an ammeter. Good job. The current is the same at all points in a simple circuit. What word could we use instead of simple there? I'll give you 5 seconds. 4, 3, 2, 1. Series circuit. Charge is measured in coulombs. Yep. The amount of charge that flows in the circuit depends on the current flow and how long it takes. Kind of. Not how long, yeah, kind of, but the amount of charge that flows depends on the size of the current and how long you leave the current flowing for. I think that's what you mean. Voltage is measured between 2 points of a circuit. That's potential difference. Its SI unit is volts. Fantastic. The higher the voltage, the more energy it gives to the electrons that are pushed out. That is an excellent answer. That's probably the best one I've read so far. Aisha. When a switch in a circuit is turned on, the potential difference in the wire creates a flow of electrons called the charge. Okay. The flow of electrons is called the current. I kind of like this. A potential difference in the wire makes the electrons flow. Yeah, I like that. There is a potential difference across the whole wire. So that's cool. This charge per second is the current measured in amps. So this bit here obviously is a bit mistaken, and you've corrected yourself here. Current is measured by an ammeter, correct? The charge is negatively charged. The charge is negatively charged as it is the flow of electrons. That's nonsense. You mean, what do you mean? Current is flowing in the opposite direction, goes from positive to negative. You mean that the electrons flow from negative to positive, but the current flows from positive to negative, I think. The charge or the current flowing through the circuit will light up the bulb. Yep. The electrical energy is transferred into light and heat. Yep, okay, not bad. Karina's, in a circuit there is a battery which transfers energy to the charge as it passes. Okay, yeah, it gives the charge energy and then the charge flows out the battery, makes the electrons move. Okay. Current is the flow of electric charge in the circuit. It only flows through a component if there is a voltage. Yeah, that's true. The voltage is the energy, and if they don't have any energy, they won't move. The battery pushes electrons from the negative terminal to the positive terminal. Yeah, correct. When the electrons flow through the bulb, some energy is used as heat to light the bulb up. Yeah, kind of, I guess. Yeah, the wire gets hot and then it glows. To stop the flow, the switch must be off or open. Again, pretty good answer. I still think Sapphire's was the best, so I'll leave that on there. To finish, it's very important you have a good understanding of what electricity is and how it works, so thanks for watching. Hopefully you enjoyed that, a different way of marking your work that no other teachers would ever do. Rate, comment, and subscribe, yo. All right.